When the protractor is removed, we can see a little bit better. Let's imagine what happens when the arc x continues its path around the unit circle. The next slide will help. The value of sine x rises quickly as x increases from 0, and then more slowly as x approaches pi over 2. So as you can see, the difference between the length of this green line and this blue line is pretty extreme compared to the difference in lengths between the purple, the yellow, and the black lines. What do you think will happen if x increases beyond pi over 2, terminating at points in quadrant 2? Take a moment to draw more points to determine sine values in quadrant 2. For consistency, use pi over 12 increments. We'll show the results on the next slide. So what we can do is reflect these points across the y-axis. So that point goes there, this point goes there, and so on. Just like that, and then we can draw in our points. The symmetry of the unit circle allows us to evaluate sine x for values of x in the second quadrant based on first quadrant values. On the next slide, we'll see the results in a table. So as you can see, points that are reflections across the y-axis, like this point and this point, have equal sine values, which is the length of these lines that drop down to the x-axis. Here is a full table of all of the sine values. So as you can see at 0, it's 0. When we get up to pi over 2, that's our maximum value of 1. But the points right around this point, so these two yellow points, both have sine values of 0.966, and that's the length of this yellow line right there. And say this line or the point at 3 pi over 4 here has a length here of 0.707, and so does this line right here, the reflected point across at pi over 4.